Hey, beautiful people. This is Coach Oakham, and I'm here to help you with the grade 8 AMI day 27. Um, Looks like we have a table here, a data table, and we have a passage. And so let's jump right into the data table. Let's look at it. It says annual sunspot numbers, and then it's got year. Looks like 1972 all the way to 2002. Looks like every 2 years there's a recorded measure of the number of sunspots. Okay, so my scale might be 2 on my graph for that axis. Okay, let's take a look at what they want us to do. It says use the data in the table of annual sunspot numbers to make a graph. Okay, so you're going to make a graph based on the data in this table. Label the x-axis year, which is the independent variable, and label the y-axis sunspot number, which is the dependent variable. Just a quick reminder that your independent variable influences your dependent variable. So in this case, the year will influence the sunspot number. Okay. Once you get your graph made, you're going to answer some questions based on your graph. One says, based on your graph, which years had the highest sunspot number? So you're looking for the maximum. Number 2 says, how often does the cycle of minimum activity repeat? So the lowest points would be your minimums. And then number 3 says, when was the most recent maximum sunspot activity? So you can read your graph to answer that question. Let's read the passage and see if we can learn more about sunspots. Our sun does not have a solid surface. Rather, the sun is a ball of glowing gas all the way through. Early observers noticed dark spots on the sun's surface. These became known as sunspots. Sunspots look small, but they can be larger than Earth. Sunspots are areas of gas on the sun's surface that are cooler than the gases around them. Cooler gases don't emit as much light as hotter gases, which is why sunspots look darker than the rest of the surface. Sometimes the loops in sunspot regions suddenly connect, releasing large amounts of magnetic energy. The energy heats gas on the sun to millions of degrees Celsius, causing the gas to erupt into space. These eruptions are called solar flares. Solar flares can greatly increase the solar wind, resulting in an increase in the number of particles reaching Earth's upper atmosphere. Where the particles hit Earth's atmosphere, powerful electric currents are created that cause the gas molecules in the atmosphere to glow. These are the northern lights. When the solar winds are too great, the particles can cause magnetic storms. Magnetic storms can disrupt radio, telephone, and television signals. So the first paragraph was really about what sunspots are and why sunspots look darker than the rest of the sun's surface. The second paragraph went into detail about how sunspots become solar flares and what happens to Earth as a result of those solar flares. And so, as you use the table to create your graph and answer the questions, I hope you've learned a little bit more about sunspots and solar flares. I hope you're doing great and stay safe out there. We miss you and we hope you're doing well. See ya.